Why am I confused here? Generating something but multiple things, and then we push it back. What? I think my expansion is really should reproduce a vector. Something like this, I guess. Yeah, let's just be able to print a vector of those things, I guess. What to do here? K is a vector of KClass, so I guess I'll just append it. I think that's the right thing there. Append one vector to another. I'll just Google it. Yeah, I guess. I'll just use this, I think. That's a bit nonsense. I'm just gonna call it K and be done with it. So let's run over the whole list. And then now K is a reference to KClass. You can just call multiply with power 4. Right. No, I think I have everything except expand. Just I also cannot print a vector. Let's add that first. So I want to be able to print a vector of K classes. It should work. At least reduce the errors. Yeah, now I just have expand. Expand on K class, right? Sorry, it returns a vector of K class. Must be a constant. dev, a vector allocates memory on the heap using malloc under the hood. And malloc is slow. So a small array is just, fixed size, compiler time, basically allocation. Fast. And you can make it a const expression. Just fill everything in during compile time. Let's see. Okay, so for those who are watching and want to know what this is all about, I don't know how many regulars are watching, but I'll quickly explain what you're looking at, otherwise it's maybe a bit too boring. Do I have here some explanations? I think I don't have much in the comments, do I? Okay, so this is about the Collatz conjecture. We apply certain steps, namely if I only work with odd numbers. So what I do is multiply by 3 and then add 1. And then we divide by 2 until it becomes odd again. And that's a single step. Okay, 0 is then all the numbers that go to 1 in a single step. Sorry, in 0 steps. In other words, K0 is just 1. No steps, so you already have 1. K1 is all the numbers that go to 1 in one step, and so on. That means that K1 would be these numbers. Each of these numbers times 3 plus 1 becomes a power of 2. So then if you divide all the 2's away, then you end up with 1. So K2 would be all the numbers that when applying one step gives a number in K1, and then the next step you get a number in K0 and so on. This is the general expressions for that. You just take any number from the previous one. If it is modulo 1, if it is 1 modulo 3, why do I say that every time? Then you multiply it with some power of 4. If it is 2 modulo 3, then you multiply it by 2, and making it become 1 modulo 3. And then multiply it with the power of 4. Multiplying by 4 does not change the modulo 3 value. So we still have then something that is 1 modulo 3. Subtract 1, so that is then 0 modulo 3, so it is divisible by 3. And that then gives you the new set. Namely, because now every number of this the new set multiplied by 3, adding 1, dividing all powers of 2 away, maybe even inclusive of that one, it gives you a number of the previous set, which is exactly what we want. And the way I store that, I store it with bit patterns. So we store it in class KClass, which is actually represented by a deque of patterns. So these are just bit patterns, and each pattern is repeated or not. I made a notation for that. For example, here, K1 can be written like this, where angle brackets means repeated once or more. So if you repeat it just once, you have 0, 1, 0, 1, and that is binary for 5. And if you repeat this twice, you have 0, 1, 0, 1, 0, 1, and that is binary for 21, and so on. And you can even do the calculations with it. I have square brackets, that means repeat 0 or more times. And if there are no brackets around it, then it's just a fixed pattern. And then you can have something like this, which means 0 or more times repeating 0, 1, 0, 1, 0, 1, followed by 0, 1, 0, 1, 0, followed by 0 or more times repeat of 2 zeros. So this represents an infinite number of binary numbers, compressed, as it were. So those are stored in KClass. KClass is one such number. And what we want to do is the operations multiply with the power of 4. That's this one. And then subtract 1, and then that's this one, and then divide by 3. And then we're done. Then we have the next k value, sorry, the next s value, the next ks, whatever. So all very simple, isn't it? And I already implemented these, but now I have to do an expand, because if you have a pattern like this, then the modulo is unknown. It depends on the number of times you repeat this pattern. If what the modulo is. The modulo, say 0, 1 repeated once, modulo 3 is 1. But if you repeat it twice, then you get 5, modulo 3 is 2. And if you repeat it 3 times, then the modulo is 0. We can't work with that during these operations. Every repeated pattern must have a modulo of 0. So if the modulo is already 0, I leave it alone. If the modulo is unequal 0, I have to repeat it 3 times in order to make it make the modulo 0. So for example, this could turn into this, where I repeated 0, 1 just 3 times. So now the repeated thing, this is 21 binary. 21 is divisible by 3, so the modulo of this thing is 0, modulo 3. And then we can work with it. This is also already multiplied by a power of 4. That is a repeated series of 2 zeros. Every time you add 2 zeros, you have multiplied it by 4, of course. And then if you subtract 1, then this becomes this. If you have a whole series of zeros here and you subtract 1, then all the zeros turn into a 1, and you have a borrow. So this 1 turns into a 0. And then finally we can divide it by 3. This just becomes a repeat of 0, 1, because this is binary 3, divided by 3 is 1. And this is binary 21, like I said, so that divided by 3 is 7. So this becomes a repeat of 3 zeros and 3 ones, which is 7. 0, 0 divided by 3 is still 0, 0, and 3 divided by 3 is 1. So the end result is this. Okay, so that's what I'm doing. I'm now going to work on the expand, which turns ks, like a pattern like this, into a vector of expanded patterns, where all the repeated patterns have a modulo of 3. That means that we have that, but we wanted to repeat it at least 3 times. But angle brackets means repeated at least once, so now we have 3 already, and it is possible to have only 1. So I have to make it square brackets, and then add a 0, 1. So now this, it ends on 0, 1, I still have that one, but then this thing here now has a repeat of ones. If this does not repeat, square brackets can be not repeated at all. then you have just 1, 0, 1. That would be the first one here. That is at least there. And then of course you have the possibility of 2 of them, so add 1 more. And finally we have the possibility of 3 of them, but I can write that like this. So the expansion should, this must be turned into a list of these 3. And then, yeah, well, I kick 1 out. This one has a modulo. The modulo of this thing is, if I say modulo, then I mean modulo 3. So the modulo 3 of this thing is 0, therefore it's kicked out. Maybe it should not even return it. I don't know. At some point you have to do that filtering. That's why I am ending up with just the 2. The first one and the last one. Okay, let me concentrate now on writing this. You see, this is why I never explain anything. Oh wait, YouTube is catching up. I start explaining, and then by the time I'm done explaining, and I look at the number of viewers, and I see 0 or 1, or everyone left. But I think we kept the people. Shashi can predict now. I start at 1 and I'm calculating backwards, basically. Because what I'm trying to do is going in the opposite direction of the normal Collatz steps. So I begin with 1, and then if we understand that, and that is probably not going to happen because otherwise other people would already have proven it to be true. But it's fun, I think. And if it succeeds and I understand the complete pattern, then maybe I can point out, you see, this is what is generated, and that there is a number that cannot be generated by this way. And then that number would be a counterexample of the Collatz conjecture. Haunted death, okay, man. Okay, I want to write expand. Did I already add it to the class? I think I did. So it took me at least 5 minutes to explain it, right? The average view time is 1 minute 36 seconds. So I'm better off not explaining anything. Because in 2 minutes from now, I have new viewers who didn't hear my explanation. Hello, hello. I guess I'm ready. What an interesting name. Damn it! Where's my class? There it is. Expand. Okay. So long explanation, and now everyone who followed it and is still here can actually follow what I'm doing. Sorry. And yeah, this is not easy at all. Not at all. Let's begin with returning simply vector of this, so we don't expand anything at all. Let's call it just result. For now, let's call it list for a change. So we're going to have a list start empty, and then as an zero order approximation, I'm just going to not expand anything. Hey, boys bunny. I guess the expanded part is the KS, right? No, I think I should print. I mean, at some point we'll have multiple patterns inside the K. Already this one should have had it. So I'm gonna say is a lowercase k, meaning it's a single element of that, although it is a pattern. So still infinite numbers of things, but anyway. I should print k, and then I should print the expanded list, I think, separately. Gives a little bit more insight. Okay, I'm printing the list. Yeah. So let's begin with printing k as itself. And then, just like here, I just do the operation. So I say expand. Yeah. So K1 is this is one element. Take the first element and we expand it, but we don't. And then we have that. And then we do operations on each element. So that seems to work. Multiplying with a power of 4 means appending 2 zeros after it. Once or more, that would be n is 1 or larger. And that is correct for K2. And then we subtract 1, that looks good. You know, these zeros become 1s, and we borrow this 1 here, so that disappears. And then we divide by 3. And that goes wrong, but that's simply because this cannot be divided by 3. And the reason that it cannot be divided by 3 is because we didn't do the expansion. So let's continue with the expansion. Right, I can expand a single pattern that is not that's work, but it's doable. But then for each pattern, for each expanded pattern, I have to expand the next pattern as well. So it's kind of a recursive thing. What kind of function can I write to capture this recursiveness? Maybe I should remove a pattern, I think. So let's write down documentation here, as it were. So we probably have some pattern. I don't know. Pattern 1, and then we have some fixed pattern, and then we have again a pattern, so we call pattern 2, and then again fixed bits, and then say we have pattern 3, And I don't know how to expand this, but I do know how to expand just a single pattern. So I think what I should do is remove the first pattern, this repeated pattern. And then try to expand that, which then in turn is going to remove everything up till and including the next pattern. And then I can So in this case I'm going to have a fixed pattern that must be prepended before the expansion of the next pattern, the last pattern. And if I make a whole list of that, man, how do you put this into a recursive function? There's copying going on, right? It's more like the other way around, I think. At some point I already have something, but not the expanded last part yet. So still concentrating on just this. You can also see that as a part that we already have, minus that. And then we want to append, expand 001. Plus there is an underflow. We have to do with an underflow from above. Say the input is indeed it's a bad example. Okay, we have now fixed followed by repeated pattern. Let's concentrate on a single repeated pattern where we only have something fixed in front of it. Let's make that fixed thing very small, like just 1. And then the repeated pattern also very small, say 0, 1. Then I know that if I'm going to split that up, like I did here, so we get append the expansion of that. Where this is the last. Does it even matter? I guess it doesn't really matter. I just need to remember the end the modulo, the rest value, let's say. Yeah, we need to work with patterns plus rest. Not the rest, the modulo 3. So let's turn it into a pair. So if this thing here has actually a modulo, the modulo 3 is 1 here. Thing. No. The modulo, the repeat of 1 has a modulo of 1, but you cannot say that. Only after expansion you know that. But okay, this fixed value does have a modulo. That is equal 1, modulo 3. I think I have to pass that. So we pass that as well. To make clear that it's not just this value, let's add something divisible by 3 to it. This also have a this is also equal 1 modulo 3, and then we just pass that 1 to the expand. And this expand now is going to produce pairs, yeah. I think. So that is then going to be the 0, 1, 0, 1, 0, 1. 0, 1, comma 1. This is repeated once, or a multiple of 3 more, and the modulo is 1. Return that as a pair. But the modulo of this is 1, and we already had a modulo of 1, so we just add those two. So again, we return this, updated with the modulo that was the rest value. However, that's not correct. No. Well, it's going to be 2, but the reason that this is 1 means that we have to overlap from the left with 0, 1s, I think. I have to add that. So this thing expands into that, but we have to add an infinite series of 0, 1s. And even more, you know, until infinity. But that then is the rest, as it were. So if we add this, then what I get is 0, 1, 0, 1, 0, 1, 0, 1. And the rest is then 2. Well, it is the modulo of this thing is 0, of course, because it's a repeated pattern. And the modulo of this is just 2. So then we return this. And then the next one is 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. And then also doubling it, basically. Well, it is we add something that by coincidence looks exactly like what we already have. But then we get again this pattern. And the modulo of that is 1. Oh, this is 10. 10 modulo 3 is 1. And finally we get this. And the modulo of that is 0, obviously. I mean, that was 0, 1, 0, 1, 0, 1 as well, and then I added it already. This should be the output of the expand when you pass 1. So it does return a vector, I guess. Nope. The problem with this approach is that I have to do it then many times. It becomes very, very, very slow. I want to do this only once, of course. Calculating the modulo should be easy. I don't have to do this. If I store it like this, I have a repeated pattern, which I know that has a modulo of 0, plus a fixed pattern. And I can just calculate the modulo of that fixed pattern if I need a modulo. Yeah, and I wanted to do it only once. So I think that instead of doing all of this, I have to, or I should, I guess, not do it like that. I should make the expansion for each pattern once. So I'm going to, we have this separated. And then each pattern is, let's make them a little bit smaller, otherwise, no, okay, three, otherwise, you know, I don't know. Let's make this 3. Let's make this, yeah, but not something divisible by 3. Let's make this just 3 ones. I'll just make this 1, I guess. Then 5. So its modulo is not 3, therefore it must be expanded. And therefore we get square brackets 1 0 1 0 1 1 0 1. Or same thing with 1 0 1. Or that. And then in the same list I can repeat this. I don't have to repeat this. Let's do it like that. So it's just clear that it's local. This is a list of 3 things. And this one expands then to 1 2 3 1 2 3 between square brackets 2 3. Yeah, I have no idea how to continue, but it seems necessary at least that we'll have a function that expands a single repeated pattern into a list of 3 KClasses, because this is a repeated pattern plus a fixed pattern. So we store that in K classes. But yeah, KClass knows what the pattern is. If pattern must know what a KClass is, we have a problem. So that must then be a member function of KClass itself, even though it takes, or maybe just a free function. I'll just make it a free function, I guess. Maybe even a new class, especially for this. Because I might also need the modulo stuff. Build the modulo stuff around it later. So I think I'm gonna make it a new class. And I call that expanded pattern. Which is then internally KClass. There's a vector of KClasses. Yes, and then we store these three values here, 1, 2, 3, we store that in the vector. Or when it is a fixed thing, I just store this into it. Then the size is 1. Maybe that's silly, but I don't know. The more everything is the same, the easier it becomes to program, I think. Not sure yet. And it must be possible to construct this thing from a pattern. So for example, given this pattern, then the result should be that we have a vector of these three things. U as a first step. Whoops, no, this is not on GitHub. This is about Collatz conjecture stuff for Christmas, and there's, the Linux viewer that the Bear gave you the link to is something else. That's a Vulkan engine that I'm working on. Expanded pattern. Well, let's write it. I guess if pattern type equals, actually I want to start to use fixed instead of once. I'm going to change that to replace this with fixed. I'm going to cook dinner very soon, 10 minutes or something. And I'll just be back after dinner. If pattern type equals fixed, yeah, then you don't do anything. So the result should be just that. Meaning we take m expanded and we push back a single, well, just constructed actually, in place back. We construct a single KClass, which is what kind of constructors do I have there for that? Nothing. That's not the nice. I want to be able to construct it with a given pattern. I'm gonna do it by value and then move it, I think. So that is a single thing, single pattern. No, I don't know. I already use normal parentheses above, and there's no confusion here. So both work, but okay. So yeah, just copy the pattern, and then I said I wanted to move it. Standard move pattern. deque should have a move operator, I suppose. So that the type is fixed, then m plays back, and then we can just construct the KClass from the pattern. It is a const reference. So anything to move it all, actually. The pattern is not that big. Pattern. Pattern has a number in it. Okay. Yeah, I should move it, I suppose. I haven't put much attention into that. Into that kind of optimization yet. But yeah, this pattern is coming from somewhere, so we'll just pause it by const reference. It's not being constructed right there. So I need then this KClass to be const reference as well. Yeah, we'll just have to make a copy at some point. Okay, that was the easy one. That was this one. Might as well make it a switch now I think about it, because I have to do something else for each case. Okay, so if it is once or more, then we have this, because this was a once or more, angle brackets. So then we have to place back 3 of them. 1, 2, 3. And they look like the following. Let's make let's construct the repeat pattern. Pattern, new pattern. Copy that from pattern. Actually, it depends on the modulo of that thing. I have to calculate the modulo first, because there's no reason to triple it when the modulo is already 0. Yeah, we don't have that. I meant pattern. Pattern itself. I really need to start using. Okay, interrupt this as well. Just this one file is enough. So now I have a text file. I have no idea how to do that, to be honest. How do I read my text file? Just simply set tags. Let's make an alias like this. Current directory is so that, then text, I guess. I was working on patterns. Right, pattern. Now we can jump at least to stuff. What was my last change? All right, I'm here. Yeah, I wanted to know the constructor of pattern. This pattern can be constructed from a number, the number of bits, and the type. So we constructed from a number, but the number must be triples. Oh no, no, sorry, wait, I needed to know the modulo. But it would be just the modulo of the pattern then, I guess. Yeah, I don't have that here. So we have to call the pattern on the pattern and then calculate the modulo from that. No. Yeah, no, the switch is not that handy actually. Okay, so now the modulo 3 is not 0, so you really have to repeat it. And the pattern type is ones or more. So first I want to get my number. Let's return simply pattern. And I have to triple that. Yeah, but how? I need the number of bits as well. Bits. Because that's just pattern.bits. A good, can I assign? I think I will make a default constructed number is 0. Yes. So I can make a number. No, I can make it. I'll make a copy. Wait a minute. Yeah. And I can just shift the bits, of course. Shifted bits. And then add pattern again. And then we do that twice. No, okay, I'll do it in a loop. So now I have this triple to pattern, and then I want to place back my number, and then the number of bits times 3, and the pattern was 0 or more. Minute. Yeah, that's just the first pattern. I also need to add something behind it, no? And what I'm constructing here is a... Let me see, I just need to make a pattern, a new pattern. So a new pattern that is repeated 0 or more times. Pattern, repeated pattern. Okay, how can I add something to my KClass? Like as in append. Append the second pattern. Might as well make a constructor of that, I suppose. Just construct 2 patterns. Pattern 1 and pattern 2. Let's make this one the most significant one, so that must be pushed last then. How to construct a pattern that is actually just a fixed value of well, let's make it extension. I don't know, pattern fixed extension. That would be just a repeat of a single pattern. So it's just basically a copy of pattern pattern as number with the same number of bits but fixed. Let me add that here. And then I have to double that one. We had that pattern here somewhere halfway, you know, when j was 1. So maybe I should store this in an array instead. Fix extension and make it an array, standard array, pattern, size 2. and then well, there's nothing, and then this is the moment you enter it, it's once, repeated once, and then the second time repeated twice. So and this is also called twice, so I can do DA and becomes a pattern constructed from the current n, comma bits times j plus 1, comma fixed. And I have to update the repeated pattern. Or not. No, wait, this is the same repeated pattern. Now I have to update it. I must make the type. So I'm just going to set type to once or more. And then we construct it from the just the repeated pattern and no fixed extension. Yeah, by now I'm interested if this works, because it's very fuzzy all, you know, not certain. Probably doesn't even compile by now. As of now, in this state, or how you say that. Shall I write this one as well? While I'm at it and stuff. Okay, so let's say if we have something that is repeated 0 times or more, so like that, then that becomes well, let's do the same thing. So this was repeated once or more, now we have repeated 0 times or more. That means that we need triple value. And then nothing, but also once and twice. So it's actually exactly the same as here, except that we don't have to set it to, well, wait, no, yeah, I don't set it back to once or more. I don't think pattern has a set type yet, though. Let's add that. I do not have default constructed patterns. I want to construct an array and then assign them. So let's add it. I'm just gonna, I don't care. But that means I do need an assignment, which I also don't have. Type is original.mtype. It compiles. No, what? So I can construct an expanded pattern from a pattern now, and that should then give me 1 or 3 KClasses. Let's attempt it. Okay, let's make this work for something that only has a single pattern, or is that not going to happen? No, that's not going to happen. Let's loop over all. Let's loop over all the stuff in M patterns. Well, that is a pattern. And then I'll construct an expanded pattern from this pattern. And then that is a list of KClasses. I guess I can just add them to the list and then we'll see them. No, it's not correct. I should just print it. and I return empty list or whatever. We have our output. That means I must be able to print an expanded pattern. Can't do that yet, so I'll have to add a operator less than, kind of like here. I guess I'll just print all. Oh. Let's print the whole vector. I could print vectors. I could print vectors already. Just print the m expanded thing. I think I could. Not clear. There's a vector of k classes. Yeah, but I have to move that up then, or declare it earlier anyway. Let's declare it. Yeah, where did I need it? The last change that I made. I need it here-ish. Nah, I just move this down. This looks very empty. Expand is nothing. And I didn't print it. Didn't print anything. How is that possible? That seems impossible. It should be constructing stuff no matter what. No, that's not going to do much. Or is it? It should still do something though. This is just k0, so it's just 1. And then loop all that, so I'm going to construct and expand that pattern from pattern, which is just 1. Fixed, so it is fixed. So we do m expanded and place back. M expanded is currently empty. And then we do m place back, and then now it should no longer be empty. Yeah, now it contains a single deque with 1 element that is a vector of size 1 with 1 bit fixed. So as expected, if you ask me. And then I print it, and apparently that prints nothing. Oh, it does print something. Oh, I'm just printing expanded without saying that I'm printing something expanded. Just change this line for more insight. Yep. By doing that, we completely kill our test. So instead, let's not call expand when it is too trivial. Actually, why doesn't it work? My list is empty, it says. Expand is and then nothing. How is that possible? So I expand it, but then this ends up empty. That's not what I want. I'm expanding it and not pushing it back or something. Oh, right. This is completely empty. Yeah, it is not clear to me. Sorry, but expanded pattern is a vector of k classes. Cannot just push that back. Oh, I can. Oh, I cannot. could you just the first one, I guess. Just the first one. So to make an accessor for m expanded. Expanded const return, and that returns a KClass vector actually. Class reference. And I can call on that, and then we have the access to my expanded. And I'm just doing the first one. Let's see what this gives. We got stuffs, and not a little bit. It got all crazy. Holy moly. My music stopped. Okay, started it again. Okay, so yes, we have k0 is 1. I multiply it by power of 4 with n is at least 2. That looks like that. Subtract 1, we get that. Divided by 3, we get that, which is correct, right? That is k1 is 5, 21, etc. Then we take that and then we expand that. And that looks like that looks really, really weird. I mean, I don't understand this, I don't understand this. This, however, is exactly what we wanted. That this is the output that I wanted. Tripled it, put it between square brackets, add 1, so this is repeated once or more, and then this is repeated once, this is or more times, etc. Repeated twice, repeated 3 times, repeated 4 times, 5, 6, 7, etc. But something went wrong here. Okay, I'm going to cook, guys, because I would have done that half an hour ago, I said. I'll be back after I did eat and etc. Yeah, sorry about that, but a guy got to eat. Post Bunny, you still here?